Hey everybody, here we have an example to solve. This is a quadratic equation. In fact, this is a quadratic trinomial of the group of polynomial equations. Quadratic gets its name because the largest exponent is 2, and trinomial because we have 3 terms, equation because we have an equal sign. When you're solving any polynomial equation, you want to make sure you get it equal to 0 first. This one is already equal to 0. If it doesn't have an equal sign, do not just stick an equal sign on it and decide you're going to solve. If it doesn't have an equal sign, look at the directions again. They probably say something like simplify or factor. They're not going to say solve. You cannot solve if you don't have an equal sign. You also can't move things to the other side if you don't have another side, if you don't have an equal sign, right? Right. So the first thing we do is we get this equal to 0, and then we're going to try to solve by factoring. Factoring is probably the nicest, cleanest, quickest way to solve an equation like this one. If it's not factorable, then you will go to the quadratic formula, which you'll see in the next 2 examples, one of which will give us 2 real solutions and one of which will give us 2 imaginary solutions. But this particular example is going to give us 2 real solutions if we use quadratic formula, but 2 imaginary, but we can solve by factoring. So I'll do it both ways. I think in this video, depending how long it goes, I'll just solve by factoring, and then I could show, like, pretend you didn't realize it was factorable and you accidentally used quadratic formula, what would happen at the end to help you clean it all the way up, okay? So let's go. So first thing we got is we have our problem here, 2x squared plus x, 2x squared plus x, which is really a 1x. So if you want to write the 1, I guess you can. I don't normally do, equals 0. The factoring method I would use on an example like this one is what we call the AC method with grouping. So that means we're going to identify the product of A and C. Okay, we're going to find the product of AC, A x squared plus B x plus C equals 0. A times C in this case is 2 times negative 10, which means, I'm just showing a lot of steps here, we get negative 20. Now you want to find the pairs of factors that give you 20, and then we'll play with the negative. Don't try to be a hero and jump all over the place, just go in order. The place you know where to stop whenever you make a list of factor pairs is at the square root of that number. The square root of 20 is between 4 and 5, so 4.5 would be your pivot point. So really you only need to test up to 4. So anytime you have a large number, don't panic. Like if you had 120, you can stop at the square root of 120. Well, the square root of 120 is just under 11, so you could really stop at 10. You only need to make factor pairs up to 10, and you're good. So don't have a meltdown next time you have a number like 120. It's really not that bad. All right. Anyhow, 1 and 20, 2 times 10, 3 does not go, 4 times 5. That's it. Bottom of the list. B for bottom. What's the B value? 1. All right. Now I need a pair of numbers that multiplies to give me negative 20 and adds or subtracts, however you want to think of it, to give you positive 1. What is it? 4 and 5. I need a positive 1 from 4 and 5. That would be a negative 4 taken from a positive 5. Negative 4 and positive 5. So we're going to use those 2 numbers to split that middle term of x or 1x. So we have, let's just scooch over here, 2x squared plus x plus, just kidding, it's minus. I need my white out. I don't want to give you guys a messy paper. So this is what I would call where you have 2x squared, which is your, I'm going to break my pen thing, it's going to spill everywhere. 2x squared is my first times first, and negative 10 is really my last times last from the FOIL method, if you are hopefully familiar. So this came from first times first. This is the last times the last. I don't have oi. I don't have the outer and the inner. I have a middle term. So this is what we have. FML. And we're going to take the M and we're going to split the M up to make the first, the outer, the inner, the last. And that's what makes it factorable by grouping. So the first will stay the same, 2x squared. The last will stay the same, negative 10. To split the outer and inner, we use these two numbers we just wrote here. Now, it's negative 4 and it's positive 5, but what goes with them is whatever that middle term has. If the middle term is x squared and this guy over here is x to the 4th, then x squared would go on to my two middle terms that I'm splitting. Also, you can use this method as long as the trinomial is of the form where this power is double that power and this has no x or variable. So 4 with 2 and no x, a 6 and a 3, no x, a 10 and a 5, no x. It's all good. Just make sure when you split that middle term, you give it that same variable situation that the other middle term has, okay? So it matches up. So x and x. And from here, you can use grouping. Some of you may take some shortcuts. I will work it out this long way and then I'll talk about the shortcut. So what's the GCF here? 2x. What's the GCF here? Plus 5. Bring that 2x out front, parentheses. Bring that 5 out front, parentheses, is 0. Reduce with the pretzel. What do I get? X, take away 2. Same idea here, x minus 2. Then from there, x minus 2. What's left inside? 2x plus 5 equals 0. So the x minus 2 is like my greatest common factor. It's super big. They both have one. Pop that guy out front. What's left after I pull that out front, see it's gone. It's not squared. It was one of them that we factored out. We undistributed 2x plus 5. Now we apply what we called the zero product property. That means you take each factor and set it equal to 0. X minus 2 equals 0. Add 2, add 2. Ooh, a little sloppy. X is 2. There's one of your answers. And then 2x plus 5 also equals 0. Subtract 5 from each side. 2x equals negative 5, but we're not done. Just like with restrictions, you have another step. Got to get x all the way alone. X equals negative 5 over 2. When you do restrictions, sorry, this is so squished. When you do restrictions, it does not equal, right? And it's only from denominators. This is solving polynomial, which has the same vibe going on. So this video, we solved factoring. Let's just do a smidge extra shortcut method. Can we? I think we can. So let's say we're up to this, okay? So I'm just going to scooch my paper a bit. It was 2x squared plus x minus 10 is 0. And let's also say we've already established negative 4 and positive 5. We still use this and we can shortcut a bit. Set up our parentheses, just jumping to that. We're skipping the steps. Outer and inner will be negative 4x and 5x. Outer and inner, okay? 2 is a prime number. It's the only even prime number. 2 is prime. What, first times first, what more or less do I have to have in here in order for first times first equal 2x squared? We don't have a lot of options. We have more than one option for 10 for last times last, so let's start with the prime one, 2x squared. So that means I'll make one of these 2x and the other one x. If I multiply 2x and x, and this, you can't take the super shortcut when the a is not 1. I hope you guys know what I'm talking about, okay? So 2x and x. Now the outer and the inner are, one of them is going to be negative 4x, the other is going to be 5x. Outer already has a 2. Do you think it's the 4 or the 5x that it will be? I'll wait. If you said negative 4x, I love you. So that has to be a negative 2 in order for that to happen. Negative 2. Now, a couple things that you can do. You get the same answer either way. Last times last is negative 10, so what needs to go right there? Or inner is 5x, so what needs to go there? You should have the same answer either way, and that's going to be plus 5. So if you notice, I end up with the same factored form, just flip-flopped, right, that we got up here. If you needed to check it, please just do FOIL and then combine your outer and inner. Please watch your positive and negative signs. Come on, guys, we got this. But I hope you understood that. Either way, this is how you solve this one by factoring. I will do a bonus video of this solved with quadratic formula, just so you can see what would happen in the situation where you ended up doing quadratic formula on something that really didn't need it, and your radical ended up simplifying all the way, and now you're like, oh no, I got to clean this up and simplify this. I got you. That'll be linked at the end here as a little bonus video. All right. Have a great day. Thumbs up if you're smart. Thumbs down if you're having a bad moment, and you'll be smart again later. All good. And talk to you later. Bye.